We can already detect whether a linked list has a loop. Now let's go one step further and find exactly where the loop begins, the node where the tail reconnects. Floyd's algorithm has an elegant second phase that reveals this, and it feels almost like magic once you see it work. There are two phases. In the first phase, we do the usual slow and fast walk until they meet inside the loop, which proves a cycle exists. Now for the clever part. We move slow back to head and leave fast where it met. Then we advance both by just one step at a time. Because of the maths of the distances around the loop, they are guaranteed to meet again exactly at the node where the loop begins. We return that node. We run the usual slow and fast walk. The moment they meet, we know there is a loop, so we reset slow back to head and leave fast at the meeting point. Then we move both one step at a time until they meet again, and that meeting node is where the loop starts. If fast reaches nothing, there is no loop, so we return nothing. Let's find the loop start of a cyclic list, then test a straight one in a live editor. A node holds a value and a link to the next node. Both pointers start at head for phase 1. When they meet, reset slow to head and step both one at a time. They reunite at the loop start. Now, let's test it and hit run. There it is. The loop reconnects at the node holding 3, so we get 3. The straight list has no loop, so we get nothing. Here is the shape. Phase 1 walks slow and fast until they meet, proving a loop. Then reset slow to head and move both one step at a time until they meet again, which is the loop start. If fast reaches nothing, return nothing. Both phases are linear walks over the list, so the total time is order n. We use only 2 pointers throughout, so the extra space is order 1. It is remarkably economical for what it finds. 3 things. First, only begin the second phase once slow and fast have actually met inside the loop. Second, in that second phase, both pointers move just one step each, not 2. And third, if fast reaches nothing, there is no loop, so return nothing.